Welcome to Do the Math America. I am Charlene, Math Shaman. This is Lesson 49. I will be using New Elementary Mathematics Syllabus D. You can purchase a copy of this textbook from singaporemath.com. I do not receive financial compensation for this recommendation. This video lesson covers the material featured on pages 238 to 242 of the textbook. In this figure, ACB is a straight line. Angle A and angle B are adjacent angles. Thus, we call angle A and angle B adjacent angles on a straight line. Using a protractor, I measured angle A to be 60 degrees and angle B to be 120 degrees. The sum of those two angles, A and B, is 60 plus 120, which is 180 degrees. We can confirm from this figure that the sum of adjacent angles on a straight line is 180 degrees. In drawing any two lines to intersect at T as shown in this figure, angle A and angle C are called vertically opposite angles. Angle B and angle D are also vertically opposite angles. If I trace this figure on another piece of paper and flip that image upside down, I can confirm that the vertically opposite angles, A and C, are equal. The other vertically opposite angles, B and D, are also equal. You can notate these angles as being equal by writing the same number of notches on those angles that are equal. So in this case, angle A and angle C will get 2 notches to indicate angle A and angle C are equal to each other, and angle B and D will get 1 notch each to show that B and D are equal to each other. So we see that vertically opposite angles are equal. This next figure shows 5 angles converging at point O. I measured each of those angles with a protractor. Now I will find the sum of all those angles which converge at point O. I write down all those angles and add them up to find that the sum of those angles is 360 degrees. I mentioned in my previous video that sometimes using a protractor to measure angles is not accurate. However, we can use another method to prove that the sum of angles converging at a point equals 360 degrees. In this case, we will take line AO and extend it, draw it out to point F, which I forgot to notate. In any case, angle D from the previous figure gets broken into angles F and G as shown. From this figure, we can see that angles A, E, and G are adjacent angles on a straight line, and they do add up to 180 degrees. On the other side of that straight line, angles F, C, and B are also adjacent angles on a straight line. F, C, and B also add up to 180 degrees. All of these angles of this figure, angle A, angle E, angle G, angle F, angle C, and angle B, are angles which converge at a point. They all have the same vertex, O, and they are called angles at a point. We can see from this figure that the sum of the angles at a point is 360 because we add those previous adjacent angles on the straight line, both of which added up to 180, and when we add those together, we get 360 degrees. At this point, I need to digress from the lesson briefly to discuss a new word, axiom. In geometry, an axiom is a statement that is accepted as true without proof, serving as a fundamental building block for proving other geometric concepts. Essentially, it's a self-evident truth that forms the basis of a geometric system. Like, through any 2 points, there is exactly one line in Euclidean geometry. Key points about axioms. No proof is needed. Axioms are not proven, they are simply assumed to be true. Foundation of geometry. Axioms are the starting point for building a geometric system, allowing us to derive other geometric theorems through logical reasoning. Sometimes called postulates. In geometry, the term postulate is often used interchangeably with axiom. Examples of geometric axioms. Things that are equal to the same thing are equal to one another, and the whole is greater than the part. Another mathematical concept I want to introduce you to is geometry theorem. A geometry theorem is a statement related to geometric figures that has been proven to be true using logic and accepted as a mathematical principle. Essentially, it's a fact about geometric shapes that can be demonstrated through proof, relying on established axioms and postulates. Key points about geometry theorems. Requires proof. Unlike postulates, which are accepted as true without proof, theorems need to be demonstrated through logical reasoning to be considered valid. Based on axioms. Theorems are derived from basic geometric principles called axioms. Example: the Pythagorean theorem is a well-known geometry theorem stating that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. We will discuss Pythagorean theorem in a later video. Okay, so what do axioms and theorems have to do with this current lesson? First, we looked at the sum of adjacent angles on a straight line is 180 degrees. That is an axiom because it is not necessary to measure every set of adjacent angles on a straight line to know that their sum is 180 degrees. That is accepted as true. The abbreviation of this axiom is written in parentheses. Secondly, we studied and demonstrated the axiom, vertically opposite angles are equal, the abbreviation of which is written in parentheses. And finally, we used the first axiom, the sum of the adjacent angles on a straight line is 180 degrees, to prove the theorem, the sum of angles at a point is equal to 360 degrees. And we abbreviate that theorem in parentheses. In this figure, AOB and COD are straight lines. Find the values of x, y, and z. First of all, we see that there is a right angle. Y plus 40 degrees makes up a right angle. So by definition, y plus 40 equals 90. Because the sum of complementary angles is 90 degrees. So y plus 40 equals 90. And we subtract both sides of the equation with 40 to isolate y by itself on the left-hand side of the equation. And on the right-hand side, 90 minus 40 equals 50. Y equals 50. So I write 50 degrees next to y on the figure. Next, I notice that angle COA, which is given as 65 degrees, and angle COB are adjacent angles on a straight line, which means that angle COB plus 65 equals 180. because the sum of the adjacent angles on a straight line is 180 degrees. So angle COB plus 65 equals 180. We subtract both sides of the equation with 65 in order to isolate angle COB. I rewrite the equation on the next line, giving myself plenty of space to show the math. So on the left-hand side of the equation, 65 minus 65 equals 0, leaving angle COB by itself. On the right-hand side, 180 minus 65, I do that work on the side, and I get 115. So angle COB equals 115. I write 115 next to angle COB on the figure. Next, I notice that angle AOD, which is made up of Z plus Y, is vertically opposite angle to angle COB, which means that Y plus Z equals angle COB because vertically opposite angles are equal. And I highlight those angles on the figure to show you what I am looking at, the vertically equal angles. And we go back into the equation on the right and substitute the known values with the variables. Angle Y is 50 degrees, so we substitute 50 for Y. Z we are solving for, and angle COB we figured out earlier was 115 degrees, so we will substitute 115 for angle COB, which gives us 50 plus Z equals 115. Now we just need to solve for Z. I rewrite the equation on the next line, giving myself plenty of space to show work. I have 50 minus 50 plus Z equals 115 minus 50. On the left-hand side of the equation, 50 minus 50 equals 0, leaving Z by itself. And on the right-hand side, I have 115 minus 50. I do that work on the side, and I get 65. So Z equals 65. I write down 65 next to Z on the figure. Next, I need to solve for X. And I notice there are adjacent angles with X along the straight line of AOB. I highlight with the red marker to show you the adjacent angles on the straight line. Once again, we use the axiom, the sum of the adjacent angles on a straight line is 180. So therefore, angle Z, angle Y, plus 40 plus X equals 180. Or X plus Y plus Z plus 40 equals 180. And we write the abbreviation for this axiom to support this equation on the side. Now we solve for X. We substitute the known values for the variables. 50 is substituted for Y, and 65 is substituted for Z, and we write those figures underneath the equation on the line below. So we have X plus 50 plus 65 plus 40 equals 180. So now we need to sum up those numbers on the left-hand side of the equation. 50 plus 65 plus 40, I do that calculation on the side, and I get 155. So I write that on the line below, X plus 155 equals 180. I continue to simplify the equation. I isolate X on the left-hand side of the equation by subtracting both sides of the equation with 155. On the left-hand side, 155 minus 155 equals 0, leaving X by itself. And on the right-hand side, I have 180 minus 155. I do that calculation on the side. 180 minus 155 equals 25. So this equation simplifies to be x equals 25. Now I can organize all the solutions. X equals 25, y equals 50, and z equals 65. I box my answer. In this figure, AB and CD are straight lines. Form an equation in X and solve the equation. First, I will highlight the lines AB and CD, showing that they are straight lines. Since AB and CD make a cross, there are vertically opposite angles I can see. The angles 2x plus 15 is vertically opposite to the angles x plus 85. And since vertically opposite angles are equal, therefore 2x plus 15 equals x plus 85. And we write the axiom which supports this equation on the side using the abbreviated form. Vertically opposite angles are equal. Now we solve for x by gathering the variables on the left-hand side of the equation and the numbers on the right-hand side. I rewrite the equation on the next line, giving plenty of space to show work. I start by subtracting both sides of the equation with 15. On the left-hand side of the equation, 15 minus 15 equals 0, leaving 2x by itself. And on the right-hand side of the equation, I have x plus 85 minus 15. I solve 85 minus 15 equals 70 on the side, and I write that down on the line below. So I have 2x equals x plus 70. Now I bring the variables to the left-hand side of the equation by subtracting both sides of the equation with x. So I rewrite the equation on the next line, giving plenty of space to show work. I subtract x on the right-hand side and x on the left-hand side. On the right-hand side of the equation, x minus x equals 0, leaving 70 by itself. And on the left-hand side, 2x minus x equals x. You can think of that as 2x minus 1x equals 1x, or just x by itself. So I have x equals 70. I box my answer, but now I need to check my work. Go back to the original equation, 2x plus 15 equals x plus 85, and I substitute 70 for x, which gives me 2 times 70 plus 15. Does that equal 70 plus 85? 70 plus 85, I do that calculation on the side and I get 155. Write 155 on the line below, and for the left-hand side of the equation, I have 2 times 70 plus 15. 2 times 70 is 140 plus 15 does equal 155. The solution is correct. The only way to get good at math is to do plenty of practice problems. The practice problems for this exercise are found on pages 240 through 242 of the book. I encourage you to take the time to do these practice problems. Some of these problems may be more challenging and require multiple attempts to find a way to solve the problem. Please don't get discouraged if you do need to spend time to think through a problem in order to figure out how to solve it. That is common with geometry problems. I can also reassure you that none of these are trick questions. In other words, you have all the information you need in order to solve these problems, and there is a solution to each problem. Please check your solutions with those in the back of the book to make sure you did the problems correctly. One powerful benefit of studying geometry is that it teaches you deductive reasoning, which offers clear logical conclusions when based on true premises, making it highly reliable in fields like mathematics and science. It provides certainty and precision, helping you make sound decisions in everyday life. I hope you found this video helpful. Thank you for joining me at Do the Math America.